Hi, in this video, I'm going to discuss valence electron, which is one of the most important topics in chemistry that any chemistry student need to know in order to understand chemical reaction. So as it turned out, not all electrons are important in the atom, but only the valence electrons are. And in fact, chemistry is the study of valence electron. On the very first few days of this class, we started out defining chemistry as the study of matter and how they interact. And later on, we do redefining chemistry as the study of electron. And now at this point, we will further redefine chemistry again, and in which chemistry is the study of valence electron. So valence electrons are the most important factor that determine the chemical behavior of an atom. So first, what are valence electrons? It's important that we keep its definitions clear before we dig into this any further. So valence electron, by definition, are the electrons that occupy the outermost principal shell. So there it is. That is the definition of valence electron. Electron in the outermost principal shell that an atom has. Versus electrons not in the outermost shell are then called the core electron. So we need to be able to determine, given an atom, how many valence electrons that it has. And it's really cool because once we see how many valence electrons that an atom has, we'll be able to predict its chemical behavior. So now, how do we determine how many valence electrons that an atom has? There are two ways. First is by using electron configuration. If we know how to draw electron configuration and orbital diagram, we should be able to use that information to easily determine how many valence electrons that an atom would have. For an example, let's say for carbon, the electron configuration of carbon is 1s2, 2s2, 2p2. So in this case right here, we can also draw the orbital diagram, and in this case we have 1s with 2 electrons in opposite spin, and 2s with 2 electrons in opposite spin. And here are the 3 degenerate p orbitals, and there are 2 electrons in them. So by definition, valence electron are the electron that occupy the outermost principal shell. So in this atom right here, the outermost principal shell, or the highest principal shell that there's electron for this atom, would then be the second principal shell. There you go. So you can see the 2s and the 2p has electron in them, and these are the highest, this is the highest principal shell where we'll find electron in. So therefore, we're going to add these two together. So this are then called the principal, or we can also call this the valence orbitals, or the orbitals that are outside that has electron in them. And when we add all of them together, there are 4 electrons. So therefore, carbon is then said to have 4 valence electrons. And similarly, if we were to have the orbital diagram, we can also use the orbital diagram to determine the valence electron as well. And in this case, this orbital right here. So there's 4 of this orbital, and this again we can call this the valence orbital. Versus this one, we can call this the core. And the electron in this would then be called the core electron. So here we can see there are 2 core electrons and there are 4 valence electrons. So quite easy to determine how many valence electrons that an atom would have. And now let's try another example. So determine the number of valence electrons in neon using its electron configuration. So in this case, let's start by writing its electron configuration first, which is 1s2, 2s2, 2p6. Now there will be the 3s, 4s, and so on, except there's no electron in them. So that's why we're not including those orbitals. So in this case right here, the highest principal shell that has electron in them will be the second principal shell. So there you go. You simply look at this number right here, number 2 and 2 over here, because this corresponds to the principal number. And when we add all of this together, there are 2 electrons here, there are 6 electrons here. So neon is then said to have 8 valence electron, or VE. And similarly, we can try another example. So in this case right here, SC, and the electron configuration of SC is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So there it's complete electron configuration. And now, how do we then determine valence electron then? Then again, look at all of this orbital right here and ask ourselves, which of this orbital right here have the highest principal number? And in this case, we will then see that it's the 4s that has this principal number 4 right here. So this would then be this 4s would then be the valence orbital. And in this case, there are 2 electrons in it. So therefore, SC has 2 valence electrons. Okay, and so basically the valence electron can be considered that the electron that is furthest away from the nucleus. So that's what valence electron would be. And in order for them to be the furthest from the nucleus, they need to locate on the higher principal shell. Now, the 3D in this case right here are being filled after the 4s. However, this 3D right here is closer to the nucleus compared to the 4s. Okay. So one is the distance from the nucleus and the other one is the energy. And when we fill electrons into orbital, we do so, we fill electrons based on the energy of the orbitals. But in terms of distance, then the 4s will be further away from the nucleus than the 3D. And that's what valence electron would be. And now let's try another example. So in this case right here, we have PT, platinum. So in this case right here, the electron configuration, so we can use the noble gas core. So in this case, it has xenon core followed by 6s2, 4f14, and 5d8. So that is its electron configuration. And now we need to figure out what would be the highest principal shell that has electron in it. And in this case right here, it is this 6s. And there are 2 electrons in it, so therefore has 2 valence electrons. And similarly, another example, chromium. So in this case right here, the electron configuration of chromium is it has the argon core followed by 4s1 and 3d5. Now remember that chromium is one of the elements with the exception to an electron configuration that we need students to understand. So it's actually not 4s2, 3d4, but it's 4s1 and 3d5, because one of the electrons from the 4s has jumped into the 3d, and therefore this is its actual electron configuration. And now when we determine the valence orbitals or the valence principal shell, in this case right here, it will be the 4th principal shell. And now there's 1 electron in it, so therefore has 1 valence electron. So quite easy to determine the number of valence electron that any atom would have if we were to have its electron configuration readily available. The other way that we can also use to determine the valence electron of atom is by using the periodic table. And it's very important that we are being able to do this and be able to recognize this pattern right here. So the number of valence electrons can be determined easily by simply looking at the group number. Group number 1, all of the elements in group 1 has 1 valence electron. All elements in group 2 has 2 valence electrons. And now we're going to skip the transition metal. Most transition metal has 1 or 2 valence electrons. In fact, most of them has 2 valence electrons, and there are few that have 1. And those are the one, the D4 and the D9 that we have discussed already, where the electron jump from the S into the D. So therefore now it has only 1 valence electron remaining. And moving on to group 13, has 3 valence electron, group 14, 4 valence electron, group 15, 5 valence electron, group 16, 6 valence electron, group 17, 17 electron of 7 valence electron, and group 18, 8 valence electron. So there you go. All of the elements in this same group right here have the same number of valence electrons. This is why that they behave chemically similar to each other.